Today we're going to talk about solving trig equations. So for our first example, let's solve the equation sine of alpha is equal to 1. And our goal here is to describe all of the angles alpha that satisfy this equation. And well, we can start by finding one angle that satisfies our equation. We know that sine is equal to 1 at the top of our unit circle, where the y-coordinate is 1. And this angle here is 90 degrees. Or if you like in radians, this would be pi over 2. And today we're going to be working in radians. Now, this angle here certainly satisfies our equation, but I could also consider the angle, what if I take pi over 2 and I add 2 pi? That would be equivalent to traveling all the way around my unit circle and then ending back at the top again, right? And so alpha equals pi over 2 plus 2 pi is another solution to my equation, right? These guys here are coterminal. Remember, coterminal angles are angles that have the same location. And we could also consider going around our unit circle, say, twice. That would be equivalent to taking pi over 2 and adding, say, 4 pi, right? Or maybe we decide to travel in the clockwise direction. That would be equivalent to taking pi over 2 and subtracting 2 pi. Either way, all of these angles are coterminal. They all have the same location, and they all satisfy our equation. And we actually have infinitely many angles that satisfy this equation. They all have the same location, but how can we describe them all? And one way to do this is we're going to take pi over 2, and we're going to add basically multiples of 2 pi, which looks like 2k pi, where k here is an integer. So for example, if k is equal to 1, well, that would be equivalent to adding 2 pi. If k was equal to 2, well, then this 2k pi would turn into a 4 pi. And if k was negative 1, well, then we would get that negative 2 pi, right? What if k was, say, equal to 3? Well, then our solution would look like pi over 2 plus 6k pi, which again is still coterminal to all of these angles at the top of the unit circle. Okay, so let's write down our solution, and we're going to do this using set notation. So remember these brackets here, these squiggly brackets, these are our set brackets. And we're going to say the set of angles alpha such that, so remember this vertical bar means such that, alpha is equal to pi over 2 plus 2k pi. And this here describes all of the angles that satisfy our equation. Let's look at another example. So example 2. This time let's solve sine of alpha is equal to 1/2. And we can start by just locating the angles where sine is equal to 1/2. And we know that that's going to happen in the first quadrant at the angle pi over 6. And also in the second quadrant at 5 pi over 6, sine of 5 pi over 6 is also positive 1/2. And so to describe all of our angles that satisfy our equation, we can consider these two angles plus all of their coterminal angles. So we can just add 2k pi to each of them. And if we want to write down all of our solutions in set notation, that would look like the set of angles alpha such that alpha is equal to pi over 6 plus 2k pi, sorry about that, 2k pi, or alpha is equal to 5 pi over 6 plus 2k pi. And there we go. This would be our solution set for this equation. Let's look at another example. So this time let's do cosine of alpha is equal to about root 2 over 2. And again, first thing is let's just locate where does cosine equal root 2 over 2. And that's going to happen in the middle of the first quadrant at pi over 4. It's also going to happen in the middle of the fourth quadrant, right? Over here, cosine is positive root 2 over 2. And for this angle, we can actually describe it as either negative pi over 4, or we could also describe it as 7 pi over 4, right? Notice when we go to describe all the coterminal angles, so we add 2k pi to each of them, Well, now these solution sets are actually equivalent. They both include one another. So now let's write down all of our solutions using set notation. So we're going to get the set of angles alpha such that alpha is equal to, and notice what we can do here. For all of these angles in the first quadrant, so we would describe these as pi over 4 plus 2k pi, right? And now in the fourth quadrant, again, we get to choose to describe it as either negative pi over 4 plus 2k pi or 7 pi over 4 plus 2k pi. But if we choose this negative pi over 4, well, then we can actually kind of combine these two equations from the first quadrant and the fourth quadrant into one. And we can say alpha is equal to plus or minus pi over 4 plus 2k pi. And this describes all of our solutions. Let's try one more example. Example 4. This time we are going to solve tangent of alpha is equal to 1. Again, first thing is, let's just locate where does tangent equal 1. And well, one way to do this is notice tangent of alpha, that's equivalent to sine alpha over cosine alpha. So sine alpha over cosine alpha is equal to 1. And if I multiply both sides of this equation by cosine alpha, what we would get is sine of alpha is equal to cosine of alpha. And so now we're just looking for an angle where sine is equivalent to cosine. And where does that happen? Well, that happens in the middle of the first quadrant, right? Because here our x and y coordinates are the same, right? Our x coordinate, which represents cosine, is root 2 over 2. And our y coordinate, which represents sine, is also root 2 over 2. And this angle we're interested in is alpha equals pi over 4. Now the other location where sine and cosine are equivalent, that happens in the middle angle in the third quadrant, right? Because here, both our x and y coordinates are the same. They're both negative root 2 over 2. And so this angle here would be alpha equals 5 pi over 4. And so one way to describe all of our solutions is we can take these two angles and we can just simply add 2k pi to each of them and then put them in our set notation and we would be done. Or there's a trick we can use for this one. Notice if we start at pi over 4, and instead of adding 2k pi, what if we just add, say, pi? If I were to just add pi, well, that would bring me around to 5 pi over 4, my solution in the third quadrant. And now if we start at 5 pi over 4, what if we just add pi again? Well, that would actually bring me to 9 pi over 4, but that's coterminal to this pi over 4 in the first quadrant. So basically adding pi instead of 2 pi is just going to bounce back and forth between our two locations in the first quadrant and also in the third quadrant. So now when we go to write down our solution set, we can write it like this. The set of angles alpha such that alpha is equal to pi over 4, so we're starting with the angle in the first quadrant, and now I'm just going to add k pi. And this is going to take care of all of our angles in both the first quadrant and the third quadrant. And there we go. This describes all of our solutions to the equation.